When installing a tankless water heater, selecting the appropriate cable size is crucial for safe and efficient operation. In this case, a 125 amp breaker is required on a 200 amp service panel with a 30-foot run of cable to the service disconnect near the water heater. To determine the correct cable size, we need to consider voltage drop and consult the National Electrical Code, or NEC. The recommended cable size for this application is number 2 American wire gauge, or AUG, copper cable. Now let's delve into the calculations to understand why number 2 AWG copper cable is suitable. Firstly, we need to determine the voltage drop. The formula for voltage drop is voltage drop equals voltage times current times cable length times 2, divided by cable resistance per foot. Secondly, we need to look up the cable resistance per foot in the NEC table 310.16. According to this table, the cable resistance for number 2 AWG copper cable is 0.277 ohms per foot. Thirdly, we plug in the values into the voltage drop formula. Assuming a 240 volt system, we have voltage drop equals 240 volts times 125 amps times 30 feet times 2. Divided by 0.277 ohms per foot, which equals 2.5 volts. Fourthly, we check if the voltage drop is within the allowable limit. The NEC allows for a maximum voltage drop of 3% on branch circuits. Therefore, the allowable voltage drop is 240 volts times 0.3, which equals 7.2 volts. Since the calculated voltage drop of 2.5 volts is less than the allowable voltage drop of 7.2 volts, number 2 AWG copper cable is suitable for this application. Understanding voltage drop and cable sizing. Voltage drop is an important consideration in electrical installations. It refers to the decrease in voltage that occurs along a conductor as electricity flows through it. Excessive voltage drop can lead to several problems, including reduced performance of electrical equipment, overheating of conductors, and increased energy consumption. The NEC sets limits on voltage drop to ensure safe and efficient operation of electrical systems. For branch circuits, the NEC recommends a maximum voltage drop of 3%. This means that the voltage at the point of view should not be more than 3% lower than the voltage at the source. To calculate voltage drop, we use the formula voltage drop equals voltage times current times cable length times 2, divided by cable resistance per foot. The voltage is the nominal voltage of the circuit, which is typically 120 volts or 240 volts for residential applications. The current is the amount of electricity flowing through the conductor, measured in amps. The cable length is the one-way distance from the source to the load, measured in feet. The factor of 2 accounts for the fact that the current flows through the conductor and back. The cable resistance per foot is a property of the conductor material and size, and it can be found in the NEC Table 8. The NEC provides tables that list the allowable ampacities of different conductor sizes. Ampacity refers to the maximum amount of current that a conductor can safely carry without overheating. The ampacity of a conductor depends on several factors, including the conductor material, size, insulation type, and ambient temperature. When selecting a cable size for a particular application, it is important to choose a conductor with an ampacity that is sufficient to handle the expected load current. The NEC requires that conductors be protected against overcurrent by fuses or circuit breakers. Overcurrent protection devices are designed to trip and interrupt the flow of electricity if the current exceeds a certain level. The size of the overcurrent protection device should be matched to the ampacity of the conductor. For example, a number 12 AWG copper conductor with an ampacity of 20 amps should be protected by a 20 amp circuit breaker. The NEC specifies the types of wiring methods that are permitted for different applications. Wiring methods refer to the way in which conductors are installed and supported. Common wiring methods include non-metallic sheath cable, or NM cable, electrical metallic tubing, or IMT, and rigid metal conduit, or RMC. The choice of wiring method depends on factors such as the location, environment, and type of building construction. For example, NM cable is commonly used for residential wiring, while EMT and RMC are often used for commercial and industrial wiring. In summary, selecting the appropriate cable size for a tankless water heater involves considering voltage drop, ampacity, overcurrent protection, and wiring methods. The NEC provides guidelines and tables to help ensure safe and compliant electrical installations. By following these guidelines, you can ensure that your tankless water heater operates safely and efficiently for years to come. Remember to always consult with a qualified electrician for any electrical work to ensure compliance with local codes and regulations. Always prioritize safety when working with electricity. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Electricity can be dangerous, and it is important to take precautions to avoid electric shock. Always turn off the power at the circuit breaker before working on any electrical wiring. Use insulated tools and wear rubber gloves to protect yourself from electric shock. Never work on electrical wiring in wet or damp conditions. If you have any questions or concerns about electrical safety, consult with a qualified electrician. To further illustrate the importance of proper cable sizing, consider the following scenario. Suppose you are installing a tankless water heater that requires a 60 amp breaker. You decide to use number 10 AWG copper wire, which has an ampacity of 30 amps. This means that the wire is undersized for the load. When the water heater is turned on, the wire will overheat and may eventually melt, causing a fire. In addition, the voltage drop will be excessive, which will reduce the performance of the water heater. To avoid these problems, it is essential to use the correct cable size for the application. Consult the NEC tables to determine the appropriate cable size for the load current and distance. When in doubt, it is always better to use a larger cable size than necessary. This will ensure that the wire can handle the load current without overheating and that the voltage drop is within acceptable limits. In addition to cable size, it is also important to consider the type of insulation. The insulation on the wire protects it from damage and prevents it from short-circuiting. The NEC specifies the types of insulation that are permitted for different applications. For example, THHN insulation is commonly used for general-purpose wiring, while XHHW insulation is used for wet locations. When selecting a cable, make sure that the insulation is appropriate for the environment in which it will be installed. Another important factor to consider is the number of conductors in the cable. The number of conductors depends on the type of circuit being installed. For example, a 120-volt circuit typically requires 2 conductors, a hot wire and a neutral wire. A 240-volt circuit typically requires 3 conductors, 2 hot wires and a neutral wire. Make sure that the cable you select has the correct number of conductors for the circuit. Finally, it is important to properly terminate the cable. Terminations refer to the connections between the cable and the electrical devices. Poor terminations can cause overheating, voltage drop, and even fire. Use the correct tools and techniques to make sure that the terminations are tight and secure. In conclusion, selecting the appropriate cable size for a tankless water heater is crucial for safety and performance. Consider voltage drop, ampacity, overcurrent protection, wiring methods, insulation type, number of conductors, and terminations. Consult the NEC guidelines and tables to ensure compliance with local codes and regulations. And remember, if you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Ensuring proper installation, correct installation is as important as choosing the right components. Sloppy or incorrect wiring can negate the benefits of even the highest quality materials. Firstly, always ensure the power is disconnected at the main service panel before beginning any work. This prevents accidental electrical shock. Secondly, carefully strip the cable jacket and insulation from the conductors, exposing only the necessary amount of bare wire for termination. Excessive exposed wire can create a safety hazard. Thirdly, use appropriately sized connectors and terminals. These should be compatible with the gauge of the wire and the type of equipment being connected. Fourthly, when making connections, ensure they are tight and secure. Loose connections can cause arcing, overheating, and even electrical fires. Fifthly, properly support the cable along its run using cable staples or straps. This prevents the cable from sagging or becoming damaged. Sixthly, protect the cable from physical damage. Avoid running it through areas where it could be stepped on, pinched, or exposed to sharp objects. Seventhly, clearly label all circuits and connections. This makes it easier to troubleshoot problems in the future. Eighthly, thoroughly inspect all work before energizing the circuit. Look for any signs of loose connections, damaged insulation, or other potential hazards. Ninthly, use a multimeter to verify proper voltage and continuity before putting the equipment into service. This ensures that the wiring is correct and that there are no shorts or opens. Tenthly, document all work performed, including cable sizes, circuit breaker ratings, and wiring diagrams. This information can be helpful for future maintenance and repairs. By following these best practices, you can ensure that your electrical installations are safe, reliable, and compliant with all applicable codes and regulations. And remember, if you are not a qualified electrician, it is always best to hire a professional to do the work for you. Understanding the NEC, the National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations. It is updated every 3 years by the National Fire Protection Association, or NFPA. The NEC covers a wide range of topics, including wiring methods, conductor sizing, overcurrent protection, grounding, and bonding. It is designed to ensure the safety of people and property from electrical hazards. The NEC is adopted by most states and local jurisdictions in the United States. It is also used as a reference document in many other countries. Compliance with the NEC is essential for all electrical installations. Failure to comply can result in fines, penalties, and even legal action. The NEC is a complex document, and it can be difficult to understand and apply. It is important to have a thorough understanding of the code before undertaking any electrical work. There are many resources available to help you learn about the NEC. These include books, websites, and training courses. You can also consult with a qualified electrician or electrical inspector. The NEC is organized into chapters, articles, and sections. Each chapter covers a specific topic, such as wiring methods or grounding. Each article covers a specific aspect of that topic, such as the requirements for non-metallic sheath cable. Each section provides detailed requirements for specific situations. The NEC uses a variety of terms and definitions that are important to understand. For example, the term ampacity refers to the maximum amount of current that a conductor can safely carry without overheating. The term voltage drop refers to the decrease in voltage that occurs along a conductor as electricity flows through it. The term grounding refers to the connection of electrical equipment to the earth. The term bonding refers to the connection of metallic parts of an electrical system to create a low impedance path for fault current. The NEC provides tables that list the allowable ampacities of different conductor sizes. These tables take into account the conductor material, size, insulation type, and ambient temperature. The NEC also provides tables that list the voltage drop for different conductor sizes and lengths. These tables can be used to calculate the voltage drop for a particular circuit. The NEC requires that all electrical equipment be properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. The NEC also requires that all metallic parts of an electrical system be properly bonded. Bonding creates a low impedance path for fault current, which helps to reduce the risk of electric shock and fire. The NEC is constantly evolving to keep pace with new technologies and safety concerns. It is important to stay up to date on the latest changes to the code. You can do this by attending training courses, reading industry publications, and consulting with qualified professionals. In summary, the NEC is a comprehensive set of standards and guidelines for electrical installations. Compliance with the NEC is essential for safety and legal compliance. Take the time to learn about the NEC and consult with qualified professionals when needed. Doing so will help you ensure that your electrical installations are safe, reliable, and compliant with all applicable codes and regulations. Exploring alternative wiring methods. While number 2 AWG copper cable is the recommended choice for this scenario, it's worth briefly considering other possibilities, although they might not be ideal or cost-effective. Firstly, aluminum cable could be an alternative. Aluminum is less expensive than copper, but it has a low conductivity. This means that for the same ampacity, an aluminum cable would need to be larger than a copper cable. Also, aluminum connections require special care to prevent corrosion. Secondly, increasing the cable size beyond number 2 AWG copper would certainly work, but it would likely be more expensive and might not be necessary. As we've already calculated, number 2 AWG copper meets the voltage drop requirements. Thirdly, reducing the length of the cable run would also reduce the voltage drop, potentially allowing for a smaller cable size. However, this might not be practical depending on the location of the water heater and service panel. Fourthly, using a different wiring method such as conduit could offer some advantages in terms of protection and durability. However, it would likely be more labor-intensive and expensive than using cable. Fifthly, it is imperative that any alternative wiring method or cable size adheres to the NEC and local electrical codes. Consulting with a qualified electrician is crucial to ensure compliance and safety. In most cases, number 2 AWG copper cable will be the most practical and cost-effective solution for this application. However, it's always good to be aware of other possibilities and to carefully consider the specific requirements of your installation. Remember that electrical work can be dangerous, and it's always best to err on the side of caution. If you're not comfortable working with electricity, hire a qualified electrician to do the work for you. Choosing the right cable and installing it correctly is essential for the safe and efficient operation of your tankless water heater. Final thoughts and safety reminders. Installing a tankless water heater involves careful planning and execution, especially when it comes to electrical connections. Always remember safety is paramount when dealing with electricity. Firstly, double-check all calculations and wire sizes with a qualified electrician before starting any work. Secondly, ensure the main breaker is turned off and locked out before handling any wires. Thirdly, use appropriate safety gear, including insulated gloves and eye protection. Fourthly, never work alone, have someone nearby in case of an emergency. Fifthly, strictly adhere to all local electrical codes and regulations. Sixthly, if you are unsure about any aspect of the installation, consult a professional electrician. Seventhly, after the installation is complete, thoroughly test the system to ensure it is working correctly. Eighthly, regularly inspect the wiring and connections for any signs of damage or wear. Ninthly, keep the area around the water heater clear and free of flammable materials. Tenthly, familiarize yourself with the water heater's user manual and follow all safety precautions. Choosing the right cable size is just one piece of the puzzle. A successful installation requires attention to detail, adherence to safety protocols, and a thorough understanding of electrical principles. By following these guidelines and working with qualified professionals, you can ensure that your tankless water heater operates safely and efficiently for years to come. Electrical work can be dangerous, and it's always better to be safe than sorry. If you have any doubts or concerns, don't hesitate to seek professional help. Your safety and the safety of your home are worth it.